Lesson 14.10 is solving exponential equations. So we're switching gears here a little bit because I don't see logs, but because we're solving exponential equations, they're actually going to use logs to solve them. Kind of like if I have an equation with multiplication, I know that I divide to solve. If I have x being squared, I know that I have to do the inverse, which is to square root. If I see exponential, I know that I have to use logs. And so this is saying 3 to what power is 80? Well, you could start trying stuff. So I know 3 times 3 is 9, times 3 would be 27. 27 times 3 is 81, not 80. So I know that it's almost going to be to the 1, 2, 3, almost 4th power. But that's not exact. I guess I could try 3 to the 3.9 power. And so again, that's getting close. But I don't want to have to keep guessing and checking to get exactly 80. So what you want to do is actually turn this exponential form into a log. And the way you do that is read it to yourself in your head that this exponent has a base of 3. So I would write log, and then my subscript number, the number that goes below is my base. So log base 3 of 80 has to equal the power of x. So that's, this and this are the same form. Look, if I turn this into an exponent, it'd be 3 to the x power is 80. That's exactly what this said. And again, the more you do it, it'll get more comfortable for you. And so here, I recognize this as change of base formula, meaning I can just put this in my calculator and figure it out. So remember that it's the number that's more on top that has to go in the numerator of your fraction. So it's log of 80 divided by log of 3. And again, this works because I'm using the same base of 10, which is the button on my calculator. So I do log of 80 divided by log of 3. Now it's going to be a decimal. We want it rounded to the nearest hundredth. So remember, 100 has 2 zeros in it, so it's either going to be 0.98 or round up to 0.99. Well, it would have to round because the next digit's an 8, so it's 3.99, which I actually found it. But again, this is rounding, so it's not as exact as having more digits like this. All right, number 2 builds on that, but you have to have your exponential part by itself to be able to turn into a log. So we actually want to get rid of the multiplication by dividing the 201. It's kind of like in this equation when we have multiplication, we get rid of that to divide, or by dividing to get x by itself. So I'm going to divide both sides by 201. So then I'll have 2 to the x power equals 67 over 201. I'll probably just leave that alone. I'm sure that's not a good decimal, but let's try real quick. Oh, it's a third, so I guess it's not bad. I could go ahead and change this to 2 to the x equals, just put a third as your fraction. And now I want to change this into an exponent, or sorry, change this exponent into a log. My base of my exponent's 2, so I would write log base 2 of a third has to equal x as the power. And then just do change of base here. So it'd be log of a third divided by log of 2. Would give me x. So log of a third divided by log of 2, and then rounded to the nearest hundredth would be negative 1.58. It does not matter that that's a 9. We're only looking at the 4 as it is. So negative 1.58 would have to be the power. Okay, let's try number 3. The exponent part is isolated. Don't worry about that 5 right now, but it's not anything plus or minus the exponent. So I'm ready to change this into a log. The log has a base of 10 of 8, needs to equal the power, which is 5 times x. So what I'm still doing is change a base with this. So I'll have log of 8 divided by log of 10 equaling 5x. So we'll do log of 8 divided by log of 10 that's going to get a decimal. So 0.9031, I'll have some digits here, and that equals 5 times a number. So now to get x by itself, all we got to do is one more step and divide by 5. Now I just leave this decimal in here so that I don't have to I don't want to round, I'll say yet, because that doesn't keep it as precise. So I'm going to just hit divided by 5, and then that gets this number. Round to nearest hundredth would be 0.18. All right, and then number 4 is similar to that too. The exponential part's by itself, so I'm going to turn it into a log. Has a base of 3 of 49 would equal the power of x divided by 4. So this part right here is going to get a number. I get to where I don't even show the work. I just know I'm taking log of 49 divided by log of 3. Hit enter. And then that number is about 3.5425 equals x over 4. Since x is getting divided by 4, to solve for x, we want to multiply by 4. So that cancels. Use the answer already in here, hit times, and it'll pull that up. And then times 4 gives me that. So x really equals 14.17. And again, all of this is to find a power that would make the equation true. All right, and then last one. It's just slightly different because it uses e, but again, this is all almost together, I guess I should say. So here's my exponential part. I don't want the times 98, so I'm going to divide it just like what I did in number 2. I got rid of the 201. So that'll cancel, and I'll have e to the x divided by 2 power equals 490 divided by 98, which is 5. So that's nice. Okay, so I'm going to put log. The base of my exponent is e of 5 equals x divided by 2. Okay, on this one, the easiest thing to do would be to change log base e to natural log. But you wouldn't have to. You could still change a base. So you got 2 options here. Option 1, let's say change a base first. Log of 5 divided by log of e. Or you could change this log base e into natural log of just 5. And that is also a button on your calculator right here below the log button. So you could hit that too. So let me show you natural log of 5 is that decimal. Let me show you log of 5 divided by log of e. You'll have to hit second natural log and put it to the first power. Close parentheses. They get the same decimal. So either way, we got that. This is 1.609-ish is x divided by 2. To get x by itself, you multiply by 2. Here, so I'm going to take this number times 2, and I get 3.22.